So the last step in the human water cycle that we'll talk about is water pollution, which I guess isn't really a step, right? We don't purposely do it, or, well, maybe we do. But we first talked about we take water out in order to drink it, and for other things. We put it back into the ecosystem and we clean it, but then we also release things into the environment that maybe we shouldn't, or maybe we're not following best practices, which is what leads us to water pollution. So I guess it's kind of part of the human water cycle, but it's like its own thing. It's not actually a cyclical thing. So here's different pictures of water pollution. It can be things like this that you think of, oh, things actually in the water, or it can be an oil spill, or, chemicals coming out, or it could be something like this, an algae bloom due to nutrient pollution. According to the EPA, so again, kind of the authorities of this, in the United States, about 40%, and this is a key number to remember, about 40% of our freshwater ecosystems are not safe enough to swim in. That's ridiculous, right? That's nearly half is not safe enough to swim in or fish in. That's unacceptable. And a lot of this is due to how we used to be, when we allowed industry to just put their chemicals in our water and didn't really regulate them. We haven't started regulating until 1972, and before then, really didn't do anything about it. And even since then, same with the Safe Drinking Water Act, yes, people may be in violation, but we might not have the resources in order to address that violation. So this number, although stark, it's getting better. It's not really getting worse. We're following the rules more. We're realizing the effects of this pollution, but still, nonetheless, a very grave number to begin with. So our pollution can be organized into two different categories. There's point source pollution, which we'll talk about now, and the next one, which is non-point source pollution. Point source pollution is pretty much what we've been talking about. There is a point, and we can see the source. So for example, here is a point. So in this case, we have this pipe that's releasing some sort of chemical, or doesn't look like a pipe, but they are releasing some water chemical mix, and we can point to the source. This chemical is coming from this company. This water is coming from this guy. And so far, this is pretty much what we've been talking about. When we were talking about permitting, it's point source polluters that are getting a permit. It's very easy to say, hey, this is your pollution, you need to do something about it. On the other hand, and what we haven't talked much about, is non-point source pollution. This is pollution where we don't know who's at fault, or at least who's specifically at fault. Here we have this agriculture farm. We talked about the runoff of fertilizers and even pesticides. Well, by the time they get to the Mississippi River, by the time they get to the dead zone at the end of the Mississippi River, I have no idea whose fertilizer that was. It could have been Bob's farm, could have been John's farm, could have been Kelly's farm. I don't know whose farm it was. And that's why it's called non-point source pollution. I see the pollution, I see the algae bloom, I see the nutrients, but I don't see the source. I can't choose the source. Or here, a parking lot. This rainbowy stuff looks pretty cool. It's actually really dangerous and shouldn't go in the environment. That's oil and gasoline. Yes, I can see it, but I don't know whose car that came from. It could be the cars in the parking lot. This could be cars that were in the parking lot last week. There's no way of knowing. So here you can see the pollution. You just can't point to the source. We don't know who the source is. Now don't be fooled. Don't think, oh, I see a pipe. That is point source. There is no pipe. That is non-point source. Here's the kind of the exception, so to speak. Here we have a pipe, and water is coming out of it. So you would want to say, aha, point source. It's coming from the company up there. But that's not always the case. This particular pipe came from this. Came from a storm drain. Well, a storm drain is collecting water and washing over all sorts of surfaces from everywhere. If we would look back to this storm drain, maybe there's a neighborhood right here, maybe there's a McDonald's right here, maybe there's a school right here, and all of their waste is going in that storm drain. So when I look at this plastic or this sludge or whatever, I have no idea whose it is. Maybe it came from that kid, Maybe it came from that grandma. I don't know. And what came from there, again, yeah, it came from a wide area. So don't think, oh, there is a pipe, it's point source. You really have to figure out, looking at the pollution coming out of that pipe, who is it coming from? If the answer is, I don't know, then it's non-point source. If the answer is, I do know, it's point source. So really wanted to emphasize this example because that can trip people up. Stormwater, for example, is non-point source. We don't know whose it was. So we're really going to focus on non-point source pollution, mainly because we've talked quite a bit about point source pollution and regulating point source pollution quite a bit already. So the issue, or kind of the source of a lot of non-point source pollution, is impervious surface. Impervious means that it cannot be penetrated. Nothing can go through it. So for example, let's imagine, goodness, I don't know why this is not working today. So let's imagine that we have, there we go, we have the ground and it starts raining. And it starts raining, and as it's raining, it's raining. An impervious surface means that this rain cannot penetrate or go through this surface. An example would be a parking lot, right? If this is layered with concrete or asphalt, that water's not going anywhere. That water's not going to get through it. An example of a pervious surface would be soil. Water lands on the soil, but then the soil soaks it up. So a lot of non-point source pollution starts with an impervious surface. And what that's doing is it's preventing that water from entering the ground. Now this causes quite a few problems, some related to pollution, but I'll talk about the ones kind of unrelated to pollution first. The first issue is that this causes an increase in flooding. This kind of graphic here shows you an example or kind of explains that. Here's two different ecosystems. Here's an urban ecosystem, a store and cars and a grocery lot. And then here's a forest with soil and grass and trees. And it rains the same amount in both areas. Well, here in the forest, you have soil to soak it up, you have tree roots to soak it up, you have grass roots to soak it up. And yeah, they might have some runoff. This shows 1,300 gallons of runoff. But compared to the parking lot, barely anything gets soaked up, barely anything gets absorbed. So what happens is all of that water just goes somewhere else and can cause flooding. 1,300 gallons versus 2,500 gallons. 25,000 gallons. So a huge difference. So the water has to go somewhere, so it just sits on top and sits on top. And that's where a lot of our flooding comes from. Now, this water would eventually, hopefully, make it into a river, but that's going to cause the river to flood. And it's going to make the river go fast, like much faster, because it's getting a whole bunch of water in all at the same time. Whereas in a forest, yeah, you might have runoff, but a lot of it's soaking up, so the water's not moving super fast. And when you have super fast running water, you get this phenomenon here. This is erosion. This is soil erosion. Literally, the water was moving so fast, it's just taking dirt with it. Unfortunate if you live on the water, but as an ecosystem, this is also ruining the ecosystem. So related both to human infrastructure and just the ecosystem structure. So that's one downside of our impervious surface. You get flooding, you get higher water flow, and eventually you'll get erosion. Another downside to this impervious surface is related to temperature pollution. As you guys know, on a hot summer day, that asphalt and that concrete is so hot. You know, there's a running joke, hey, you can fry an egg on that thing, just like this, right? It is so hot, you can literally cook on it. I don't recommend doing this, or at least I don't recommend eating it. But the point being, it gets really, really hot. It's sitting there baking in the sun, and especially asphalt being so dark, it's absorbing that solar radiation a lot easier. Well, if you get a rainstorm over this impervious surface, over this really warm impervious surface, well, the water lands on it, and the water heats up. the heat that was in that asphalt is transferring to the heat, or transferring as heat into that water. And just like before, that water's going into a storm drain and through the storm drain into the ecosystem, and it enters the ecosystem as really hot water, a high temperature water. Well, that really sucks for the organisms living in there because the organisms don't want that hot water. And depending on the species, that warm water might actually kill them. There's no chemicals in it, but it's just the huge change in temperature that can shock the organisms. And even if it doesn't kill them, maybe it shocks them to a point where a predator can just easily eat them. So this would be an example of temperature pollution. And then finally, and probably the thing that you and I can affect the most, is runoff. With this impervious surface, water lands on it and it just collects everything that's on that surface. This could be actual trash that you see on the ground, or it can be things like chemicals, like that oil in the parking lot. Because that water isn't seeping in, it's literally just carrying that trash and those chemicals with it into a storm drain, into a body of water, sorry. So 3 big issues with our impervious surface. And again, all of this is an example of a non-point source. This cup or this bag right here, I don't know who made it. I don't know where it came from. It came from that drain, but I don't know whose it was. And so that makes it really hard to regulate it because you don't quite know who to regulate.